I went and got an oil change last month, and they said nothing's wrong with it. But like,
That's probably
my car's a piece of shit.
What happened?
My car had to like, I don't even know. I don't even know.
Did you oil light come on or something?
No, because my oil lights, I don't even think I have one of those.
You just have
It doesn't turn on.
the red light on the
When I
bottom.
was in high school, okay, so my mom burned the transmission out. She burned another transmission out. Then in high school, me and my sister like decided to never get an oil change. So like,
Well, when you turn the key, can you hear it trying to start? Or does
no, it starts right away.
It does? Okay.
But like, it struggles getting up to like 40 miles an
I
hour.
bet you it's nearly. Actually, or it could be, it could even be this.
Well, do you have a lot of miles on it?
I don't
Because
even
if you
know.
have a lot of miles, that can.
And sometimes,
I think.
like,
Same with
transmission
my
and
dad's.
stuff in the cold, sometimes some cars, because the car I used to drive used to have a really hard time in the winter, but in the summer it was fine.
Well, it was fine in the summer. Well, it was bad in the summer too.
Could just be a shitty car.
They're having problems getting up to speed.
Eventually, 1 inch of
Yeah, that's great. Or you
Change
might just need to come out.
No.
I don't even know.
I thought there was going to be one, but
Guarantee
she
we've
must
never
have.
changed it.
Just rebuild a couple lessons.
Yeah.
You might just, yeah, you might just want to throw in some cleaner into like a gas.
I gotta go get that shit figured out, but I don't know how, I don't know when. Next week will be the best.
Sorry about that. I'm back. So let's take out our notes so that we can get these things written down here. One of the, well, maybe a little remembrance of what we're talking about here. So remember yesterday we were getting into our discussion about heart rate, and the formula that they gave us was a generalized formula, which said 220, I forgot what it was now, 220 minus the age. Okay. Let's talk about these 5 different comparisons to that and what they have in common. Question 1. What form are these? Oh, I should ask question 0. Question 0. Are these linear functions? What leads you to say they're linear? There's a clue. No variable has a power. Okay? If a variable has a power, it's not linear. Okay? So no variable has power. Question number 1. What form are these linear equations in? Now, Sam said intercept-slope form, and the thing I like about the way they wrote the intercept-slope form is they wrote the intercept first and then the slope. I would like it if they would say the intercept-slope form is b plus mx. Wouldn't that be kind of cool if they did? Then we would never get it screwed up. Everybody would call it intercept-slope form. Everybody would start with the intercept first, right? But the thing that I really like about this 6 different ways, if you count our 220 minus the age, is that we can automatically compare all of these different representations. The first thing that I'd like you to notice is, are you writing these down, by the way? Because it's important that you do. Is that all of them have a different intercept than the one that's on in our book, 220 minus the age. That reminds me, I got a picture on my phone from the gym. Yeah, Phil, you can retake the test. I don't know if I've got a online version in the textbook or not, but I do have an alternative version that I can send you. Just email me and I'll send it to you, okay? I'm assuming you're there.
Yes.
Okay. Okay, let me see if I can find that picture. Oops. That's not the way to find it, Kevin. Too many pictures of the grandkids, that's the problem. Don't have enough room for all the pictures of the important things. Like math problems that I come across at the gym. Ooh, no, that's not it. Oh, are we getting close? No. Do you have them all written down yet? Okay, keep going. Keep writing. Oh, there it is. Oh, there it is. Oh, there it is. So I was at the gym last fall, and they had the formula that you see here. Now, why would the gym want to have a formula for heart rate? Well, they got it up at the title. What do they say? Cardio? Question mark. How much? Question mark. Because they want to make sure you know you are working hard. Did I tell you about my daughter in cross country? Okay, so she ran cross country when she was in high school. And every time she'd run past me, because we went to all our meets, I mean, we'd take care of our kids. So anyway, and every time she'd run past me, she'd be smiling. And I'd be like, do that. You are not running hard enough. How do I know? Well, because you're smiling. They make machines, right, that keep track of how hard you're working out. Right? They make those machines on purpose so that you know, I'm working out hard enough. Well, that's the same thing for this at the gym here. 220 minus the age minus the resting heart rate divided by Y. I'm not sure what the Y is. Times 0.65 equals blank plus resting heart rate. I don't know what exactly they're trying to tell you. I saw the sign, and this is the first time that I looked at it, except for to see that they had the same 220 minus the age. So I have a question for you. You guys are young and I am old. Which one of us can have a higher heart rate? Maximum heart rate. Okay, right? Because the bigger the number you're subtracting, the lower your resting heart rate, or your maximum heart rate can be. So they don't want old people like me to be doing stuff that raises our heart rate too much, because we'll keel over, right? And they don't like old people keeling over. Well, I suppose they probably don't like young people keeling over either. But we've got our heart rates here, and we're going to compare them. So the first comparison we made is that 220 seems to be a little bit too big, doesn't it? But what did they do in each one of these that made that 220 less hard to live with?
From the last equation on your phone?
Or any one of these. What did they do? Notice the age is not the whole age, it's a fraction of the age, right? So in which one of these 5 formulas that you see here do they make the most out of age? They say age is the biggest factor. Which one? And how can you tell? Eric, you got an idea?
0.75.
Yeah, the healthy Hispanic women. Okay, so they're saying for healthy Hispanic women, the biggest determining factor of your maximum heart rate is your age. Which one is the least important?
Male athletes.
Does that make sense? If you are athletic, it doesn't matter how old you are. In fact, being athletic helps you live longer. Okay, there's a guy at the gym. He's probably 65 years old. He has muscles. I mean, the guy must work out all the time. Okay? Nice guy. I shouldn't have said that. Muscular people aren't nice. I don't know where that came from. But anyway, you get the idea, right? If you are athletic, you can be any age and still be in good shape. This math class is not just about math. It's about lifestyle too. Start taking care of yourself, because when you get to be my age, you'll look back and you'll say, yeah, I'm glad I started taking care of yourself, rather than, man, I wish I wouldn't have eaten all those Snickers bars back in the day. Okay. Let's look at the assignment here. Number 2, choose. We should go back to number 1 first. Number 1, based on what you read about maximum heart rate, list one variable besides age that might influence which model you would choose about an individual's maximum heart rate. What are the factors besides age?
Smokers, non-smokers.
Okay, lifestyle. Smoking, non-smoking. Body fat, yep. Gender, right? And there was one more. Oh, nationality. That's a big one. If you are black, what do you absolutely need to pay attention to? Blood pressure. I had a friend, and I don't know why we got to be talking about it, but we both had gone to the doctor, and his blood pressure was 220 over something, and I was like, whoa. And he said, yeah, I know. So the doctor put me on blood pressure medicine right away. Why is blood pressure such a good indicator of the chance of bad things happening to your body? The more blood pressure you have, the easier it is for blood vessels to burst. Most common places they burst?
Heart.
Yeah, the aorta. Okay, and the other one is the brain. In the brain, they call them strokes, and in the aneurysms is aneurysm is when it expands. Stroke is when it bursts. And I'm not real sure about that. But I had a friend who was about in his 40s, and he had a history. His family had a history of aortic aneurysms, and his aorta burst, and he died, almost immediately. Okay, it's just so taking care of those important things is important. Page 111. Let's look at the bottom there. Choose a model that you investigate and use it for the rest of this activity. Indicate which model you plan to use. So we are going to split them up. First choice. Who wants which one? What do you want, Sam?
I want sedentary men.
Sedentary men. There you go. Do you want sedentary men who drink beer?
Well, I mean...
Okay, that's part of the process. Okay, so their group has sedentary men.
We'll take men taking beta blockers.
Men taking beta blockers. Speak up.
All right.
Yeah, sure.
What do you guys want, Menominee?
Male athletes.
Ooh.
I want male athletes.
I want male athletes too. Nope, that's already taken. Who's left? Caucasian women, Hispanic women,
Okay, cupcake.
Caucasian women. Jessica? That you only have one choice left. Sorry about that. I'll take that. Okay, so Hispanic women. So, you're going to go through with your group, and we're going to need you to report out the answers to the questions on page 112, because each one of you is going to have different answers. What happens to the maximum heart rate in the standard model as individuals' age increases? What happens to the maximum heart rate in your model? Number 4, describe 3 ways you could determine at what age your model predicted the same maximum heart rate. Part B, determine at what age your model predicts the same maximum heart rate as the standard model. And what is that maximum heart rate? Step 5. Which of the 2 models predicts a lower maximum heart rate and for what range of ages? Got it? Go. And while you do that, I'm going to take attendance.
Oh, it's good.
Is that because it's decreasing?
How is the top is
Nick's here. Michael?
Yep.
Marlena?
Yep.
Gavin? Janae? Felicia? Nicole? Eric?
Yep.
Phil?
Yeah.
Grant?
He's not here.
Connor? Paige? Eric? Laura? Madeline? Sarah? Jessica? Lauren? Jake? And Sam. All right. I'm gonna go to my Desmos and do the graphs here.
what we're doing. My math affirmation.
Everybody need more help?
Yes.
I am capable of learning and doing math. Dang it.
There it is.
I swear that's the biggest thing I need to learn at the end of this class.
Are you guys done?
Shall we? Oh, Daddy.
Oh, okay.
I need help. I don't know what I'm doing. I just plug it.
Okay, which one you, I would suggest you take out your phone and let's work in decimals.
I'm so confused. What were we supposed to do?
Okay, well, number one, you gotta be on page 7E. That's the first step. Oh, you were.
I don't understand.
Okay, so we're ready. Okay, so let's graph two things. We're gonna graph the one that they gave us.
I'm gonna graph it. This one.
Great.
Well, you see what I did? You see what I did right there, though?
Yeah, you made a table. Good job. Yeah, that's right. So, why don't you graph it as a function, h as a function of a. So h of a
I'm going in after this class.
equals 220 minus a.
Oh.
Okay, that's the first one. Let's graph your other one. Which one are you guys doing? H of a.
For our equation.
Then you have to do that arrow thing.
Yep. And now equals. There you go. Okay. Now do the other one, which is beta blockers is H of a equal
I don't know what the max is.
164 minus 7a. Okay, now let's think. Our x-axis is the age, so change your x-axis appropriately. Yep, you do the wrench. So it's probably going to be from 0 to maybe 80 years old. Right? Okay, and then your maximum heart rate is going to be somewhere between 220. That'll be the highest it is. So the lowest maximum heart rate better be about 100. So go from 100.
You showed it to us earlier.
Does that make sense?
Yeah.
Okay. Now, if you notice, that wasn't quite enough for your person because yours don't match up until you're over 80 years old.
Very.
Okay, here we go. The first one that I have listed here is H minus 207.62A. Who are you? 207.6 minus 0.62A.
Caucasian women.
That's why I'm looking at you guys, because that's your group. Okay. The red is the Caucasian women. The black is the 220 minus age people. Okay? So go through your answers, people.
3, the first one, the heart rate max decreases for both of the models.
Okay?
And then 34 years old is when they would equal each other.
And what is that maximum heart rate at 34 years old?
185.
Okay. Now, one of the things that I was thinking about on the way to school today is we really got upset yesterday when we couldn't solve those equations by elimination and substitution. Remember when we were trying to do that yesterday? It was very frustrating. And the thing is, that's a really small part of math, isn't it? Because we can do it using Desmos or using some form of technology. This is not an easy system to solve. Well, the 220 minus A isn't bad, but that 207 minus 0.62A, those fractions and decimals, why don't we use technology and solve it the easy way? Okay, so that's the first one. I'm going to turn that off, and I'm going to go to 213 minus 0.75A. You are the blue line. Who are you? There you go, Jess.
So they both decrease. And then I said they matched up at age 25 at 100.
Uh-oh. Do you know what you did? How did you solve it? What did you? You did use Desmos. Let's look at your equations just to make sure, because it's possible you're right and I'm wrong.
Yeah. You just, well, I think you can just actually use used the 196.
Okay.
And then just
I might have turned off the wrong one.
above that.
That's what I did wrong. I screwed up. Jess is right. I turned off the wrong one. I turned off the 220 minus A. So she was right. 25 years and maximum heart rate was 195. Everybody good? Next one is 196 minus 0.346A.
You changed the equation on us, so we have to fix it.
Oh, I did?
Yeah.
What should it be?
No, like above you had the wrong one. In
Oh.
your like little explanation or whatever at the top for no,
My
it's
notes are wrong?
In Desmos. In Desmos. Or the app. Scroll up.
Yeah,
That says 98.9
for male.
plus 0.4.
And what should it be?
196 0.77 minus 0.346.
Oops, not E. 3, 4, 6. Sorry about that.
It's minus, not plus.
Do I have plus?
On all of them, you have plus.
Wow, what a way to go, Kevin.
Math affirmations, Kevin.
Whoa.
Yeah, isn't that something? If I'd say I need to affirm that I can do math.
I got it. I figured it out. I didn't know.
My high school math teacher would always say, "Oh, trivialities." The correct answer, trivialities. He would say. I thought that was funny. Okay, did you get 35 years and 184?
36 years.
Oh, yep, you're right. I rounded wrong. 36 years and 184. Now, the thing that I like about this one is it shows that even if you're my age, if you are athletic and you're male, your maximum heart rate should still be about almost 180. The thing I like about that is you shouldn't have to modify your lifestyle just because you get old, right? At my age, you should still like going up to Boundary Waters and lugging a canoe for a 2-mile portage, and then going across a lake that's 3 miles long. You should still like doing stuff like that. Yesterday when I was flipping the boat over to winterize it, I was thinking that exact same thought. I was like, man, I pity the day that I will not be able to flip my boat over anymore. I'll just feel like, No, did I tell you I made the decision never to climb on top of the roof again? I was up there, I'm blowing the leaves out of the gutters, and all of a sudden I got kind of a whoop like that, and I was like, well, this is time to quit going up on roofs, because once you start feeling tittery on top of the roof, it's time to quit being on the roof. Okay, good job. Next one is 164 minus 0.7a. Who are you?
That's us.
And what did you find?
You increased your bowl, but it's slower per hour mile.
And
It takes longer to cross.
they don't ever cross during a person's normal lifespan, right?
They cross at 186.
In other words, who are you guys doing? Male beta blockers. The first thing you notice is if you are taking beta blockers, there's something wrong with you. I mean, I'm not saying you're stupid or something like that, but there is something wrong, right? First of all, what are beta blockers for? Yeah, their purpose is to slow down the heart rate. Okay, their purpose is to correct some abnormality that's taking place that was actually caused by a lifestyle choice that you made, which is too much of this and not enough of this, right? You get the picture. Is that everybody? Or do we have this one left? 205.62 minus 0.425. Is that anybody?
Yeah, that's us.
That's you guys. What was your group?
We found the ages to be the same, around 25. The maximum heart rate for that, 195.
Hey, who else had a maximum heart rate of 195? That was Jessica. That was you, right? Was that this one right here? Yeah. So, what's kind of interesting is that, and you guys did male sedentary, and you did Hispanic women, and a sedentary male at 25 years old has the same maximum heart rate as a female Hispanic person who is 25. I was going to go back. Let's compare female. I'm going to take off these two. Let's compare female Hispanic and female Caucasian. That's these two, correct? If you notice, in both cases, the slope is about the same. So there's not that much genetically different between Caucasian females and Hispanic females, which probably leads you to, if you were doctoring these two clients, what would you say? Well, I'm not going to pay attention to what nationality you are because it's kind of the same, right? Let's do sedentary males and athletic males. Here's the athletic, and sedentary is that the 0.7 one? The 0.425? Okay. Sedentary and athletic males, in both cases, it's pretty much the same thing. The biggest change is when you are in your 20s. And that's why, I don't know if you've ever seen, but they'll have things on TV. Make sure you talk to your doctor before you start any, exercise program. Have you ever seen that? Yeah, and that's an important thing to do because the doctor is going to say, did I tell you that the doctor said don't run a marathon? Because I went to the doctor one time and it was around the Eau Claire Marathon, and I said, I'm thinking about running in the marathon, and he said, yeah, don't. And I said, why is that? And he says, well, you don't know what happens to your body after you've been running about 10 minutes. Like, the whole thing rebels against whatever you're doing. That's why they have outhouses along the way when you are on the marathon. You've run the marathon?
No, I did a half a marathon.
Yeah.
And I know exactly.
He said, your body's going to rebel, Kevin. You do not want to do that. All right. Do you feel better about linear equations than you did before? That's the most important thing that I want to do with you today. Chapter 9. Do you notice that we are skipping chapter 8? The reason we're skipping chapter 8 is it just talks about ways to solve linear equations, systems of linear equations, and we already know how to do that. Let's go, I'll write it down just so that you remember it. Systems of linear equations. How are you going to do it? What are the different things you can do to solve them?
Substitute.
Okay, you could substitute. Could use elimination. graph in Desmos and
Do the like polynomial.
polysymal 2. Okay. Raise your number of fingers on your confidence level with solving systems of equations. There is a test question on systems of equations, so you need to be able to do it for the test. Yeah, yes.
I had a question. So you emailed me or you texted us?
And I emailed you back and I said, yeah, that sounds like a good way to do it.
Okay.
Yeah. Somebody wanted to email me just the answers, and I was okay with that. Somebody wanted to print it off and give it to me, and I was okay with that too.
Okay.
Any one of those ways will work. All right. Chapter 9. Carmen and Daniel want to enlarge the rectangular garden that they share. First, Daniel digs a 1-foot border around 2 sides of the plot. Then Carmen digs another 1-foot border around 2 sides that Daniel dug. Who dug more area? How would you convince someone that thinks Daniel and Carmen dug the same amount? Hey, do you guys in Menominee have a whiteboard up at the front?
No.
No.
Do you have a whiteboard any place?
No.
Okay, so you're going to have to do yours on paper. Okay? But we're going to go to the whiteboard. You guys can go to this one right here. Middle table, you guys can go to this right here. And then, Jess, you can work with these ladies, and you guys are going to be over here. And it would be nice if you would work down at this corner, because it's easier for me to get the camera turned to this corner than that corner. Okay? So, come up with a plan, draw a picture, do the solution. You have to get out of your chair and go and stand by the board. That is my only requirement.
So we have to write.
Yes. I don't care if you write. I just need you to do... No, I do care if you write, too. Go!
What page is this on?
Page 123, maybe?
Oh, skipping it.
That's what I said. We're skipping chapter 8.
Oh, sorry.
Oh,
Are you guys working together there in Menominee?
Because
Yeah.
Okay.
So
it's elected.
this is the version.
I'll take my paper out.
So yeah, I'm just doing this.
who's gonna draw?
Oh god, okay.
I'm gonna draw.
Boxes. That's boxes.
Madeline, you don't need to be quite that exacting in detail. We need to see more of the math than the artistic nature thereof, please. Why are you making those two numbers there? Yeah, where did those come from? I'm just asking. Because later on it says 3 by 5. Yeah, you're right. But it doesn't matter if it's 3 by 5.
What's the question?
I have had all my.
Yeah, I do.
Oh, never mind, Nicole had it.
Did I ever tell you about the time that I wrote on the whiteboard with a Sharpie, and it was actually this room? I told the students, okay, let's get out of here quick. I'll call the custodian and see if they can. This was before it got fixed up, before the whiteboard was in the front. So, yeah, it was not a proud day. So all of your hard work you erased.
Yeah, they told me it was bad.
That was not very nice of you.
He said it. It's more of a natty accusation, but I can draw.
That, how do you know for sure that's wrong? Like, how would you?
Yeah, you're the only one that knows.
It's like all the way. Well, no. Here's the thing. Wait. Okay. This is one by. So that side is what, 3, 4, 5 feet. Because you add the 3 feet.
Yeah, and then the one in the middle.
Y'all studied up for
So really, connect this. That's
The other thing that happened today is that I used to erase with my fingers, and then I would go like this.
So
That was when I taught physics. I did a lot of erasing.
I mean, I don't know what else you can do.
So everybody makes them 3 by 5. Hey, Menominee, can you guys take your paper up to the TV so that I can see it, just to see what you did? Not the TV, the camera. Taking it up the TV won't do any good. Other one.
No?
Other one.
Oh.
There you go.
Sorry.
Okay, just hold it there. Okay, so what did you come up with for an answer?
We're working on that.
Oh, okay. All right, you're on the right track.
Do you want like an actual?
I want an answer, because so far you have not convinced me of anything. You've got some really good dimensions, and all of them are correct.
So we're just now we have to explain why.
Well, first of all, answer the question. What was the question I was asked?
Area.
Who dug more area, and how would you convince somebody who said they dug the same amount? Which kind of makes sense. They dug the same amount because each one added a foot, correct? So they should have dug the same area if each one added a foot. She had more footage that she had to dig, right? Because he had a smaller garden that he was working with. She had a bigger one that she was working with. Got it? Okay, so start convincing. How much more? Who dug more? Oh, they've got some actual math. I like it. Now, my question to you is, if this wouldn't have been 3 and this would have been 5, if it would have been any size garden. Any size garden. So you just happen to choose, don't erase your picture. Draw a different one over here that applies to any size garden. Any size rectangular garden.
Okay, bye.
Okay, there you go. Ooh, you can't find anything? I will agree you can't find something.
7 plus 1 plus.
But you can find something that's really crucial, regardless of how big the garden is. You can find something that is absolutely important.
You also just find.
No, you know what I'm trying to do? No, you take 5.
Very good. You're on the right track. She's getting close. Because you see what she's saying? She's saying this part right here is the amount that Carmen dug. Now we have to compare how much, whatever his name is, Daniel dug. That is the exact same as that. So draw a line that helps us. You see what she's saying? Would you agree those two are the same? So write the same.
I don't know.
Yeah. Everybody agree?
Yeah.
Now you're on the right track.
Introduction, something we're going to do next.
Ta-da! Now, what's the part that's not the same? How much is that part? Shade it in and tell me its size.
6.
How wide is it and how tall is it? So, write it up there. Now my question to you is make a different garden over here and make it not 3 by 5. Make it any size. Just draw a garden. Don't give me any sizes. Okay? And do the same math. Are you guys... Let's see what you guys have.
Cut in half.
Explain your math.
And then it would be 2, 2.
So basically, you find areas that are subtract.
I don't really know.
Well, I think we just have to kind of do the same thing.
But it's not the lines. No, keep that.
And 11 is bigger than 9. Okay, so let's go through the math what we did. This is 15 because it's 3 by 5.
I'm not saying
How big is this garden here? Well, if it's one more foot this way, making it
So if we do it differently.
5, one more foot this way, making it 3 plus 1 is.
Oh,
4 times
wait a
6 is.
so if we do
Okay, and then the top garden, how big is this whole side here for the top garden? Right? How big is this whole side here? 5 times 7 is. You didn't just didn't put down
The whole top?
the math. Why don't you write equals,
No, it
equals,
would be
equals?
5,
Help,
6, 7, 8.
help your teammates. Not math challenged. I will be patient with myself when learning math. Okay. Okay, so he said 15 and 24 are 9 apart. 24 and 35 are
So we could do it a different
11. Right?
Oh, got it. Yep.
So if this is 11 apart and this is 9 apart, everybody think 11 is bigger than 9. Now, here is what you did that is different than my diagram. Notice my diagram doesn't have 3 feet.
oh yeah,
Does your math work for any size garden?
for this one,
How did he even
anyway,
find
is
out
that
the
annual?
15? Well, like,
Because he did this part down here.
Yeah, and then we could.
Garden is, suppose it starts out being 3 by 5. So he read ahead. I wanted him to do it as though it's any garden at all. That's what I'm wondering. Does anybody have some good math?
49 minus 45.
Rocky,
Yeah.
you want to see if this is
Yeah,
close
I'll
to what you want?
Yep. Yeah, show me. Okay, so you have, you're good. Just hold it there. So you guys did the 3 by 5 also at the beginning, right?
Yeah, and then here, that's
Yeah.
the formula that it should be.
So 35 minus C, 24 minus D. What did you get for a answer when you got done? How far apart were they all together?
30.
multiply those together.
9.
It's not back to that.
And then the other one was 11 apart, correct?
Oh, yeah.
One was 9 apart and the other one is 11 apart?
Sure.
Okay, so that's right, you're on the right track. Here we go, we're going to get an explanation from, oh man, I don't remember how to control the camera.
We drew it really far down.
Okay, since I focused on you guys first, give us an explanation. I don't care who's talking. Jessica is, it looks like. Yeah, that's you, Jessica. You're on TV.
Okay, so what am I explaining?
Oh, sorry, I'm in the way.
You're explaining how this works. Oh, you guys reverted to the.
I don't know what you want us to do for the
Okay.
second drawing.
Okay. Let's look at their first drawing first, because that's kind of.
It's just like a
When I said. Yeah, that's as far over as I can go. So explain your first drawing, Laura.
So we just put in all the like dimensions and stuff, and then we multiplied 5 by 3, and that's 15, and then 5 by 7, which is 35, and you subtract it to get the area of these two.
Okay, so 35, that was your area of the big garden. And what was your area of the medium-sized garden?
15.
No, that was the small garden.
Oh.
35,
Yeah, that's a lot. Like the
20. What was the medium-sized garden? 24, and then the small one was 15. Okay, so what did you get for the difference between the big and the medium? You said Carmen dug 11 feet and Daniel dug
9 feet.
9 feet. Now, Carmen dug 11 feet because she dug 6 by 5.
7 by 5.
Yeah.
She dug 7 by 5, but that 1 foot you don't want to count twice.
Oh, yeah, gotcha.
So she dug 11 feet, and then Daniel dug
9 feet, so that's
9
a 2
feet.
foot difference. 2 square foot difference.
Very good. Okay, let's look at, thank you very much. Appreciate your work. Just don't be quick to leave your drawing. You did a good job. Let's see over here. I don't know if I can get all the way over to. That's as far over as it goes.
Can you change the direction of the camera
I can-
facing the classroom?
I can try a different camera. I can try speaker track 1. Okay, I want to focus on this one right there. Okay, this is our best attempt that anybody made of explaining any size garden. They said the garden is what dimensions?
X by Y.
X times Y. Oh, you guys erased your math.
Oh, sorry, I didn't.
Your math was the best part.
Oh.
Okay. Would you agree that that garden, to be a rectangle, is going to have some kind of an area where it's X by Y, correct? So Daniel dug X. Oops, I gotta go down a little bit here. Daniel dug. Okay, Daniel dug. Can you move over just a little bit, Eric? Yeah. Other way. Okay, so Daniel dug X plus 1 times Y plus 1. And then Carmen dug X plus 2 times Y plus 2 minus Daniel. Okay, everybody got the math? Good job. Last group, just keep that up there because we're going to use that math. Last group, explain what you did.
I like the way you explained it.
Yeah.
That doesn't help us any. Am I going the wrong direction? Yes, I am.
I mean, you're still good at teaching it. I feel like it'd be best suitable if you were the one that was describing the drawing.
Okay, I like what Nick was doing here and his group. Nick, start talking.
I tried.
Alright, so I have this for the original square and subtract from this one to get 9. And then I did the new one and subtracted from the 9. And because 11 is bigger than 9, this has more changed area than this one.
So, for a 3x5 garden, how many square feet more did Carmen dig than Daniel? Everybody got the same answer. What was that number?
2.
2. Sit, everybody. Thank you. So, let's go through it. The original garden. Oops. I have to do something. You can't see that. Let's see here. Share. There we go. The original garden. Let's use the way that Sam was going about it. He said the area was X by Y. Okay? Why is that better than saying it's 3 by 5? Well, 3 by 5 shows that it works for one garden, but we really would like it if we could show that it works for any garden, right? So that's the advantage that we have for working with any size garden that has dimensions X by Y. Okay, then let's go to Daniel. He said, or their group said, it was X plus 1 times Y plus 1. What do you get when you multiply that out?
Plus X plus Y. Plus 1.
So how much more did Daniel dig than the original?
XY plus 1?
X plus Y plus 1. Make sure you don't,
Sorry.
because this XY cancels this XY. Everybody good? Am I making sense? So then let's go to Carmen. She dug X plus 2 times X or Y plus 2 minus the amount that Daniel dug, which was XY plus X plus Y plus 1. Everybody agree? That's how much Daniel dug? Am I making sense? What does this multiply out to be?
2XY. And 4.
So, let's do some canceling. Everybody agree that this part cancels. Everybody agree? If you take 2x minus x, you get
X.
If you take 2y minus y, you get and if you take 4 minus 1, you get. So how much more did Carmen dig? This is how much Carmen dug, right? This is how much Daniel dug, right? How much more did Carmen dig than Daniel dug? Does it matter whether the garden was 3 by 5 or 4 by 2 or 17 by 38 or 1,000 by 2,000? It doesn't matter. It's always 2 square feet more than Carmen, or Daniel Doug. We will start on page 124 when we get back.
Yeah, that makes sense.
Good.
Oh, I thought it was. Okay, they added the video to my site.
What class is that? Is that a tablet class or do you go core? Which one of the science
Yeah, I don't know if I have much of that anymore.
Well, neither do
Let's get on the quiz for the test.
History. It's right now.
Can somebody erase the boards while we're waiting?
These are the ones.
Public safety, what's your emergency?
The door by room 201 is locked.
Yes, they're just resetting the door system, the locking system, so it'll be unlocked shortly.
All right, thank you.
You bet. Bye-bye.
They should tell people that. Yeah, we know. Everybody's locked out. Yeah, we know.
That's fine.
That's okay.
Just tell them.
When you do stuff like that, you should send somebody to the doors, or else why would you reset it during the school day?
You can reset it at night.
You could reset it during the middle of the night when nobody should be coming to the doors anyway.
Sorry, that's too easy. We gotta play games in this building.
That's the part. Because we at the door, just be like, all right, time to go home.
Psych.
things that make you like
Yesterday and Monday.
wonder for people's sanity levels. I just don't get it
And
at
we have
all.
a read home for Wednesday, and then we have to read home for Friday.
Everybody back? Okay.
Just sort of an intro.
Oh, did I take attendance? I don't remember.
Yes, you did.
Yeah, I did. Okay. Okay, so here's the math that they did for the garden. They said, well, you take 3 and you add x feet to its width, and 5 and add x feet to its length. And so the garden is going to be 3 plus x by 5 plus x. Notice in both cases that whatever width we have that we're adding is going to be the same on the width as it is on the length. So that's why they could use just one variable as opposed to the 2 variables that we needed. Okay? Then it says, why can you take this equation here, 3 plus x times 5 plus x, and why can you write it as 3 times 5 plus x times 5 plus x? That is an important step to be able to understand why you can do it that way. We distributed this first part, the 3 plus x. We distributed it and said, well, we can take the 3 times the 5 plus x, and we can take the x times the 5 plus x, and we haven't changed the problem any. Next step down, it says, expand and simplify the formula to write its form ax squared plus bx plus c. So we get, here we get 15 plus 3x. Here we get 5x plus x squared. Notice we have 5x and 3x. We can add those and get 8x. They'd like us to write the x squared first. And we get that as the form ax squared plus bx plus c. This is the standard form. Okay. We can do that exact same math using, they call it the lattice method. And I want you to learn how to use the lattice method for multiplication. So we're going to take x plus 3 times x plus 5. X times x is
X squared.
x times 3 is
3x.
5 times x is
5x.
and 3 times 5 is
15.
got it? So our math is x squared plus 8x plus 15. They want us to do the math that way. Page 125. In connection with our original garden was 15 square feet. G of x is 15. If we added 1 foot to it, Nick said that we got 24 square feet. If we added 2 feet to each side, we got 35 square feet. Now, parenthetically, I'm just going to say this is 3 by 5, this is 4 by 6, this is 5 by 7. Notice each number increases by 1. So if we add 3 to each side, our math is going to be 6 times 8. Got it? Which is 48. So this, I'm just going to write math here. D1 stands for the first difference. Okay? How far apart are these two numbers? How far apart are these two numbers? Why don't we have a first difference here? Because there's no number before that, right? You see how you can't have a first difference if you don't have that. Does anybody want to speculate what comes next?
13.
Right? Because 35 to 48 is 13. 9, 11, 13.
15.
Okay? And let's check the math. That'd be 7 times 9, which is 63. Are these two numbers 15 apart? Yep. So 5 and 6, fill in those two numbers in the table and their first differences. D2 is the second difference. In other words, it's the differences of the differences. Notice we can't do this one, so there is no second difference between 9 and nothing because we don't know what the nothing is. But we can do 9 to 11.
2.
11 to 13.
2.
13 to 15.
2.
15 to 17. 17 to 19.
2.
Got it? For A. How much area did Daniel dig You guys had the math. How much did Daniel dig?
9 feet.
He dug 9 square feet, right? Where is that on the table? It's his D1, correct? Next one. How much area did Carmen dig? 11. That's her D1. Part C, how much more did Carmen dig than Daniel dug? 2, right? Where is that on the table? It's Carmen's second difference. Emily, Felipe, Gwen, Horace take turns at digging an additional 1-foot border. What is the area of the garden when they finish? 99 square feet, right? Each one dug 2 more square feet than the previous person dug. Sketch the graph of the function g on the interval from 0 to 6. Okay, so here's my function. 0, 15, 1, 24, 2, 35, 3, 48, 4, 63, 5, 80, 6, 99. Is this a linear function? No. How can you tell from the table that it's not linear? Oh, I forgot a very important fact. What does that fact mean?
D1 is the slope.
D1 is the slope. If these numbers here are 1 apart, you have to make sure these numbers are 1 apart. If x increases by 1, the slope has 1 as the denominator. So the change in y, which is d1, d1 is the slope. So let's think about it. What that's saying is from here, from 124, or from 015 to 124 has a slope of 9. This has a slope of 9. This has a slope of 11. This has a slope of 13. This has a slope of 15. This has a slope of 9. Oops. I missed a number. 17, and this has a slope of 19. Right? Because you go over 1 and you go up that amount. Okay? If we were to graph the slopes, let's do that. Let's graph the slopes. We see that at 1, the slope was 9. At 2, the slope was 11. At 3, the slope was 13. At 4, the slope was 15. At 5, the slope was 17. At 6, the slope was 19. What do you see is true about that orange line? Oops, I just gave it away. Sorry. It's a line. It increases by the same amount each time, by a constant factor of 2. So the slope keeps getting steeper and steeper. Let's go back in our notes to quadratic functions that we had, a long time ago. Let's go back to that page in our notes. Okay, we had a linear function, we did exponential, we did periodic. The one we didn't do is quadratic. So let's fill that in our notes. A quadratic function has a constant second difference. Is it always going to be 2? No, it's not. If we're talking about gravity, the second difference, you can't find it in your notes? It was way back, lesson 2 or 3. About how many pages into your notes are you, Nicole? She's about 4 pages into the notes, 5 pages into the notes. There you go. You got it, buddy. Okay, so we're talking about quadratic functions, and notice the formula is something to the second power. Our variable is to the second power. That's the distinguishing characteristic of a quadratic function. The distinguishing characteristic of a linear function is it's to the first power. The distinguishing characteristic of an exponential function is we've got the is the variable. And then in a periodic function, we're going to have some kind of a trig function like sine or cosine or tangent. Okay. Now, the inverse of a quadratic function is the square root function. But the part that I want to show you is the table. This is important. If we start with the point 1, 4, and the second point is 2, 5, notice we can't have an AROC or a first difference. Notice I didn't call it first difference then because we weren't ready for first difference yet, but now we are. You can't get an AROC in the first place because there's no number to subtract from. But in the second case, we increase from 4 to 5, so that's an increase of 1. We can choose any number to increase that by. In this particular table, I chose to increase it to 2. Okay, I could have said increase it by 3, which is what we would have done in our garden example, right? Because we had the first differences were 2 apart. Okay? If this were gravity, I would be increasing it by 9.8, or decreasing it, by 9.8 if I'm dropping a rock or throwing it up in the air, right? The second difference is 2 minus 1, or 3 minus 2. Okay? The important thing is the slope grows linearly, or in other words, the slope is a constant value. Okay, so let's just play around. Do you guys all have it copied down? Everybody good? Take a picture of it if you don't. Ready? Okay. So, x, f of x. Give me, let's give our inputs. Okay. Give me a value for f of x. If x is 0. I don't care what number you choose. 4. So, on our graph, over 0, up 4. From this point, we could do linear, exponential, quadratic, periodic. We could do anything, right? We don't know which one we're going to do. We want to make sure it's quadratic. So we can do one more point. Give me a value for 1. Nobody knows?
2. I don't know, I just made that up.
Good. 2. So over 1, up 2. Okay? Everybody good so far? Could we make it linear? Sure, we could just draw a line. Could we make it exponential? Sure, we could go through those points. Could we make it a periodic function? Well, we could be going down and then back up again, right? We could be doing anything. Remember, we want to be talking about our first difference. So what is the first difference here? Don't say 2. Everybody agree it's negative 2? We're sloping down 2. Okay? Now, the next point can't be 0. Why? Because if it's 0, this is negative 2, and then it's linear. right? We can't have it be negative 2. So you can choose any number you want to for this 2.
1.
Okay? What is the first difference there?
-1.
What is the second difference here? So over 2, we were down 1. What is the second difference? -1 minus -2 is?
-3.
Nope. Negative
Yeah.
1 minus -2.
1. I was right.
This number has to also be 1. What number minus 1 is 1? I'm sorry, minus -1 is 1. Very good. Which means this value here must be
1.
What does this number here have to be?
1.
What number minus 0 is 1?
1.
What number minus 1 is 1?
2.
See what's happening here? Do you see any pattern developing here? 4, 2, 1, 1, 2.
It's a parabola.
It's a parabola, and so this number is?
4.
Let's check the math. From here to here is 2. From here to here is 1. Everybody agree? Okay. So how far down did we have to go before we could say it was a quadratic function? We had to get all 4 of those points before we could say it was a quadratic function, because we had to get the second differences to be the same number. Once we got the second differences to be the same number, our pattern is set. There is a test question in which you have to decide, is this function exponential, linear, quadratic? What is it? Okay? Well, we could have gone through these 2 points and had it be linear. We could have gone through these 3 points and had it be exponential. But once we go through these 4 points, 1, 2, 3, 4, the only thing it can be is quadratic. Okay? Kind of interesting stuff. Page 126. Is the graph linear? The graph of g of x. No. How can you tell? Because it doesn't look straight, right? How does the steepness of the graph change as x increases? As x increases, the steepness increases, right? And can you think of a different way to label the first difference? What did we say it was? For part C, the first difference is the slope. Good. So, here's the rules for a quadratic function. Oops. Rule 1. The second differences of a quadratic function are
The same.
constant. Good. The most popular wrong answer is 2. Dang it, every time we take the test, the most popular wrong answer is 2 because the one we started with, the second difference was 2. But really, we've been dealing with quadratic functions since the beginning of the course. The very first day, we had negative 4.9 t squared plus 20t. I can't remember how fast you were hitting the tennis ball up into the air. But that coefficient was not 1, meaning the second difference wasn't 2. The coefficient was negative 4.9, which meant the second difference was 9.8. The second difference is always twice whatever that first coefficient is. Okay? The first differences are well, I did it on the graph. It was orange. First differences are linear. Good. And the graphs of a quadratic function are, I think it was Grant that said it. Somebody over in Menominee said it. What shape?
Parabola.
Parabola. Got it?
Grant's not here.
Page 127. When a football is punted into the air, when is it moving the fastest? When you kick it, right? Right when it's kicked. When is the other time that it's moving at that exact same speed?
Before it hits the ground.
Yeah, just the second before it hits the ground. I've got a video here for you to watch.
D'Angelo Smith waits for the punt. And this one hits the score. I don't know the officials saw it.
So the very first game that they played in Texas Stadium, a punter hit the scoreboard.
In talking to Walt Anderson before the game, he said the interesting thing is we haven't been told whether it's a reviewable play or not. Look at this. During the punt, the ball hit the scoreboard, and by rule, the play will be.
Hey, could any of you kick the ball so that it would hit the scoreboard? Not unless you were a high school football punter or something like that. Okay? Most folks can't hit the scoreboard because most folks don't punt good enough. Oh, this one's a nice one. Let's see here. Come on. Oh, Coles. Why did I click Coles? Oh.
That's it. It's got to land in the purple? No, this is clear the goal line. Once it goes in the purple, you're on to the next round, and we'll just keep backing up until we get a winner.
Okay, so from the 30-yard line, 70 yards in the air. Kaboom.
Nice job, Pat. I think you're going to gain about 1,000 Twitter followers because of that.
Hey, Warhawks, this was taken in Stevens Point, huh?
Travis Bolts from Maryland. Look at the terrapin go. Marquette King. Oakland Raiders.
This guy is awesome beyond belief. Look at that.
Didn't turn
Kaboom.
over either. That didn't turn over.
So now they're kicking from the 20-yard line. Or 25, I guess.
That's the ball. Maybe short.
Nope.
Going? All right, the terrapin advances. Pat McAfee show.
I'm going to go to the end here just to see how far the last guy can kick it.
That will work.
So there's an 80 yards in the air.
Marquette, that is gone.
85 probably, huh? Amazing.
Don't make me go. Out. Demasse, champion. 515. It's a great ball.
I missed the last one.
Demasse, champion. 515.
85 yards in the air. Amazing. Here we go. Oops. In our book. A professional football player is capable of punting the football so that its height. Notice they're not talking about distance in this case. They usually don't talk about height. They talk about, for punters, what do they want them to have?
Time.
Hang time, right? So they want the time to be really big. The way to get a really big hang time is to have that 24T get bigger and bigger and bigger. Let's go through all of the quadratics that we've had up to this point. Okay. The one we just got done with was the garden. And if you recall, the formula was area as a function of x equals x squared plus 8x plus 15. And our D2 was 2, right? Okay. The very first one that we did was tennis ball. And we did height as a function of time was negative 4.9 t squared plus, first lesson, I forgot what it was, 20t? Is that how fast we were hitting that thing in the air? Anybody look back and see it? 20t. How much is gravity? Negative 9.81, I think it is. Okay. Then we had the drop a rock. And that was height as a function of time was negative 16 t squared plus 200. Remember, we dropped the rock from 200 feet. And gravity in that case was negative 32. Okay, then we had golfing on the moon. And we had height as a function of time was negative 1.6 t squared plus 56t. Does that ring a bell? And gravity in that case was negative 3.2. And now we've got punting. H of t is negative 4.9 t squared plus, I can't read that far away. What is that number? 24.5t. And gravity in this case is okay. Now, I want you to see a relationship here between this number and this number. 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 A, the leading coefficient, is half of the second difference. The leading coefficient, the one before the x squared, is always half of the second difference. Okay. So let's go through and fill out this table for the football punt. I will do 0 seconds on my calculator. So I'm going to take negative 4.9 times 0 squared plus, oops, you can't see that, plus 24.5 times 0, and I'm going to get 0. So I'll fill in my line on the table. If time is 0, distance is 0. That's interesting. I guess I could have figured that one out for myself. So, Menominee, do 1 second. Ladies in the back corner there, do 2 seconds. Middle table, do 3 seconds. Front left table, do 4 seconds. And I'll do 5 seconds. Everybody ready? Shout them out.
19.6.
1 is 19.6.
29.4.
2 is 29.4.
Yeah.
3. Did you do the wrong math?
No, in your calculator you have a minus sign in front of the 24 for starters.
Oh, it's supposed to be plus.
Yeah.
Negative 4.9 times 5 squared plus 24.5 times 5. Oh, that's important. Okay, what do you have? 4 people. What you have? Okay, D1. Notice, I don't have to worry about D1, do I? Okay? So, do your D1, people. Menominee, what did you get?
Change is 19.6.
Ladies, what did you get? Oh, I'm working on it right now.
How do you find the D1 again?
Take the
difference.
so they took 19.6 minus 0.
Okay.
9.8.
This one is easy, whoever you guys are.
Negative 9.8.
Everybody agree? D2. Okay, I can't do D2. Menominee can't do D2. Right? What'd you guys get? Ladies? 9.8 minus 19.6?
Negative
0 minus 9.8? Negative 9.8 minus 0? You see a pattern, Nicole, is what you're telling me, huh? Notice the second difference is constant. Part B says, what is the average rate of change in each of those intervals? So we got each of those intervals. During which of the intervals is the average rate of change the greatest? Well, when you go from the beginning to the first second, and when you go from the fourth second to the fifth second, correct? In other words, when is the average velocity of the ball the greatest? Right after you launch it and just before it comes back down. All right? Are the second differences increasing, decreasing, or constant? Constant. According to this model, at what values t is the ball at ground level? Zero and 5 seconds. How long is the ball in the air? 5 seconds, right? Using a graphing calculator or app, sketch the graph of h of t on the interval from 0 to 5 seconds. Okay, here we go. 0 to 5 seconds. I've got it here. H of t is negative 4.9 t squared plus 24t. Okay, so the first thing I want to do is I'm going to make my graphs that I go from 0 up to about 5.2 seconds. And then my height, I can make my height so that it's like 34. And I can start at 0. I don't need to start at. Okay, so there's the flight of my ball. I'm going to make a function of it here, parentheses, a comma, h of a, close parentheses. Oops. And let her rip. Ooh, that's going way too fast. Well, I don't need the ball to go any farther than from 0 to 5 seconds. And I probably don't need it to go backwards. So there's my ball going up in the air, coming back down again. Got it? Number 7, it says the graphs of a quadratic function are called parabolas. We already knew that. Parabolas are U-shaped curves and can have an open part facing upwards, which would have a positive coefficient, or facing downwards, which has a negative coefficient. The vertex is the point at which the curve changes direction, or the top of the curve. That's the vertex. The vertex is also called the turning point because up, stop, going up, down, down, right? So that's why it's called the turning point. Give the coordinates of the vertex of this graph. Well, what's interesting is if you graph it in Desmos and you click on the graph, it will automatically give you the vertex. Does it make sense that the ball starts at 0, gets back down to the ground at 5, and it's at the top at 2.5 seconds? That matches what we did yesterday, right? Does it make sense that it's 30 meters up in the air, 30.625 meters up in the air? Yeah, because he kicked it so that it was he kicked it really fast. Explain how the maximum and minimum values are related to the quadratic. Would you agree this is a maximum? What's the relationship between that and that leading coefficient? The leading coefficient was a negative, right? So if the leading coefficient is negative, you've got a maximum. If the leading coefficient is positive, you've got a minimum. Got it? So our garden, when we graph our garden, will be a parabola going down and coming back up. Down and coming back up. Okay. Page. 130. Match the graphs with their equation. A, B, C, D. I gotta zoom out. Go. Oops, there's 2 more of them on the next page. On the homework this weekend, we will not be doing 9C practice because we didn't quite get that far. Letter A matches with Roman numeral nobody knows? 3, good. Letter B matches with Roman numeral 1. Letter C matches with Roman numeral 4. Now, when they say maximum value, they mean the f of x. They don't mean the x, because x, everybody agrees, can go on forever and ever in both directions. So it won't have a maximum value. Letter D, minimum value is -2. Roman numeral 2. Letter E, the formula is x squared, or the formula for letter F is -x squared. Remember what I said, if it's x squared, it's going to be open up. Right? If it's -x squared, it's going to be open down. So which one is letter E? 6. And letter F? 5. Got it? See you next time. Ooh, I sound like I work at Quick Trip. Not if I see you first. Ladies at this table, we have a lot of confusion about the My Math Lab, and I need to clarify what our head is. To me, it seems to be obvious. There's due dates, and some of the due dates are that's okay because it should still be open. You should be able to go in and do that. What you may be confused is there's tons of assignments. That's what may be confusing. But they're really short. 11-4, November 4th. Everything that says November 4th, except 9 or.
Oh, see, look what you did, Bill.
9 point. I know that, but it goes to those. Because what you need to do is not class this week. For the stuff we're going to do in class next week. I think it goes up to 12.
That's right. Sneeze this in until he takes the quiz.
I've got everything listed in order. Everything. I do not. I have not yet because I wait until morning.
Up until 12.
Is that what it said? I can't remember. It's around 12 points. So do the previews, the ones that then you see.
Up until 9.
9B. Don't do 9C because we didn't get that far.
Super cool. Yeah, which one?
And then if somebody's in contact with Lauren, she is equally confused.
If there is 2,
Don't do B. That won't be
sign up on like
previews.